Welcome to our first sample solution from exercise group 9.2. And what I want to do now is 9.2.1c, which is on page 416 of your textbook. And what we're going to do here is, again, just test a set to see if it's consistent. The first sentence is, for all x, if f of x, then gxa, and that's a set member. The second sentence is, there is an x, f of x, and that's a set member. And the third sentence is, for any y, it's not the case that gya, and that's a set member. All right, let's evaluate our tree. We have two universally quantified sentences on lines 1 and 3, and one existentially quantified sentence on line 2. So we know the rule of thumb here. Now it's getting tired by now. Let's decompose line 2 by instantiating to the constant b. We cannot instantiate to a because a already appears on the branch. So what I have to write down here is f, and then instead of x, a constant that isn't a. So let's say we do fb here, again following our practice of just using the alphabet in order. And so we say that that one comes from 2 by existential decomposition. Okay, when we evaluate our tree now, we notice that we've got two universally quantified sentences. And one of those two sentences has an f of x in it. We'll have some hope of closing a branch here if we substitute in for x the constant b, because the f of x appears as the antecedent in a conditional. So I can anticipate that when I decompose this after substituting in the b, one of the branches is going to have not f of b, and that's going to close with this f of b. Now, if you can't quite see that yet by thinking several moves ahead, that's okay. That will come with lots of practice. For now, let me just show you how that unfolds. If I now instantiate to b, I would get fb horseshoe gba from 1 by universal decomposition. So I don't just blindly instantiate to a because I've already got it, or to b because I've already got it. I do it to b because I anticipate that that will lead to a closure. And indeed here, if I immediately decompose the one on line 5, just using my standard conditional decomposition rule, you'll see that I get not fb on one side and gba on the other. And that comes from 5 by conditional decomposition. And now you see what I meant before. I've got not fb here and fb up there, so the branch on the left-hand side closes. So now on the right-hand side, what I've got is gba. When I look at my tree, the only two sentences that are not decomposed are the one on line 1 and also this one on line 3. Now the one on line 3 is very interesting because it's the negation of gya. And because it's a universally quantified sentence, y can be any constant at all. So for example, I can substitute in b. And that's really handy, because if I write down not gba as coming from 3 by universal decomposition, I can close my tree.